as with the last example, the first thing I'm going to do is just rewrite the formula for my function. I like to factor out what I'm multiplying by x. And at the very least, if it's negative, you should factor out the negative. I'm going to factor out the whole -2. And then that would be times the quantity times x minus pi over 6. Okay. When I'm factoring out a -2, of course, that's going to change the sign of each piece. And we're basically dividing by 2 or equivalently multiplying by 1/2. So that's going to double that denominator. Quick check, if I distribute the -2, yes, it does give me back the original function. Now that negative sign applies to the entire rest of the input. My input is the opposite of 2 copies of x minus pi over 6. Sign is odd. Opposite input, opposite output. So this is going to be negative sine of the quantity 2 times x minus pi over 6. Now, all of this stuff is affecting my input. That's going to affect the graph horizontally, but by putting that negative sign in front, I'm multiplying by -1 after I plug into sine. That's going to do a vertical flip. Okay. So it doesn't change the value of the high, the middle, and the low y values, but it does change the path we follow in connecting them. All right, let's deal with the horizontal stuff. I know that sine is going to do its thing once as the input varies from 0 to 2 pi. And now my input is 2 copies of x minus pi over 6. Let's divide through by the 2. So 0 less than or equal to x minus pi over 6, less than or equal to pi. And now we add our pi over 6. I'm going to just come over here to write that out. I'm going to have pi over 6 less than or equal to x, less than or equal to pi, which would be 6 pi over 6, plus pi over 6 is 7 pi over 6. Okay, so what's the new period? Well, it's the original period divided by whatever the absolute value of whatever I was multiplying by. If I use this version, I'm dividing by 2. If I use this version or this version, I'm dividing by the absolute value of -2, which is the same as the absolute value of 2. Either way, 2 pi divided by 2, I'm going to get pi. Generally, once I've rewritten things, I'm just going to do everything working with that new version. Okay, so that means that the increment is going to be pi over 4. So what are my x values? Well, that's kind of interesting because we're starting at pi over 6, but we're adding pi over 4. I'm going to need a common denominator. Looks like the least common denominator would be 12. Okay, so pi over 6 is where I'm starting. I'm going to just write below it that that's the same as 2 pi over 12. And pi over 4, if I were to multiply that by 1 in the form of 3/3, that would be 3 pi over 12. So I'm going to be adding always 3 pi over 12. So 2 pi over 12 plus 3 pi over 12 would be 5 pi over 12. That does not reduce. Okay. Plus 3 pi over 12 would be 8 pi over 12. Now I wrote that down here just because that does reduce. That's going to be 2 pi over 3. Okay. 8 pi over 12 plus 3 pi over 12 is 11 pi over 12, which does not reduce. 11 pi over 12 plus 3 pi over 12 is 14 pi over 12, which will reduce to 7 pi over 6. Okay, so writing the fractions not in lowest terms as well as in reduced form can make that finding of the x values a lot simpler. Okay, so now I'm going to, let's see, I think I can do the graph over here so I don't have to erase anything. I'm going to mark off my x values, and then I'm making sure I don't forget I've got to do this vertical flip as well. Okay, so I think I'm going to mark off that interval, that length is pi over 12. I'm starting at 2 pi over 12, which was pi over 6. And then my increment was 3 pi over 12. So 1, 2, 3 of those takes me to my next x value of 5 pi over 12. 1, 2, 3 more of them takes me to my next one, which reduced to 2 pi over 3. 1, 2, 3 more pi over 12 takes me to 11 pi over 12. And 1, 2, 3 more takes me to my end point of 7 pi over 6. So notice the tick marks that you draw don't necessarily have to only coincide with the x values that you're marking off. In this case, pi over 12 gave me that common denominator, so that marking that off I found fairly helpful. Okay, so now I know that my high value is 1, middle is 0, low value is -1, but we've done a vertical flip of sign. Now sign always starts in the middle, so at pi over 6 we'll be at a middle value of 0, but then since we've done a vertical flip, we're going to go down instead of up. So at 5 pi over 12 we're at -1, at 2 pi over 3 we're back at 0, at 11 pi over 12 we're back up here at 1, or not back there, we're now at 1, and at 7 pi over 6 we are back at 0. So I can connect the dots, make sure I've got an arrow at the end, and over here I can see that I'm going to cross the y-axis. Let's see, my increment was 3 of these tick marks, so I won't be at a high value of 1 until I'm over here. So I'm going to cross that x-axis, or sorry, that y-axis, close to but a little bit below 1. Okay, excellent. That gives me my graph. Now, we didn't start with something that looked like we had a combination of horizontal and vertical, but because sine was odd, we were able to pull that negative outside and turn that into a vertical flip, which is just easier, I think, to work with, because we're saying this gives us our starting point and our ending point. And I like it when that starting point is to the left of my ending point, so that I'm not trying to graph things backwards, which is what I'd have to do if I divided through by a negative instead. Okay, so in the next video we're going to start putting it all together, taking a look at combination of vertical and horizontal transformations for a graph.